All right, I had a student come in with this gene model that was actually looking really good in the dot plot, but they weren't feeling confident in their findings. They wanted to know what's going on here and what is going on over here. And does that mean that my gene model is wrong? So we went over the genetic distance of the project and how small changes like this make sense in the context of the genetic change we expect to see because of the scope of the project. But she still wasn't really feeling it. So I said, all right, we're going to run one test to see if this change is compatible with the function of the gene. We're going to look at domains. And domains being the building blocks of these sort of superstructures of these peptides that make them do the job that they have to do in the first place, what we would expect to see in a gene change between species that is still compatible with the function of that gene is the conservation of domains. So the first thing to do is to go to Flybase and take a look at what domains we expect to see in this gene. So the first stop is always going to be Flybase, and you can scroll down and you can see the protein signatures under Interpro and Genoprot. And what we see here is a spattering of cyclin domains. So the question is, where are these domains located within the gene? And for that, we can actually go over to Interpro. Now, I've already done this search, but the way that you would do it is you would want to go into the gene record finder. You would want to click on the isoform that you're looking to examine, ideally the longest one. We would expect that within any given gene that the domains are conserved throughout all isoforms. I don't know for certain if that's something that we should lean on though as TAs. But all you need to do is go into the melanogaster browser. You can get there by clicking on Gene Record Finder, and then just like you would pull from the NCBI RefSeq gene models, you click on one of those isoforms, you go to translated protein, and there you go. You can copy and paste. Now, I've already done this search here. So I'm just going to pull that down. This is what your results are going to look like by default. I like to make a change where I go into options and then I go label by name, because what that allows me to do is just by a quick read see cyclin, cyclin N, cyclin like, and all those other things. And I can hop over to Flybase and go, yep, cyclin, cyclin like superfamily, N terminal. Did I have an N terminal? Let's see. Yep, we've got the N terminal, which is roughly right here. And it looks like all of these domains are accounted for. So what this is telling me is that in Drosophila melanogaster, all of these domains here are clustered in the middle of the gene from roughly 225 nucleotides in, or sorry, peptides in, all the way down to roughly 450. So we're looking at the middle section of that gene needing to be intact in order to have a conserved function. And what that gives us as far as interspecies variation is concerned are these regions of flexibility. That is not a technical term. That's just what I call them for ease of understanding, where we can have some changes up here and we can have some changes up here and still have a functioning protein. And by functioning, I mean an orthologously functioning protein. So we can, if we'd like to, take a look at what our peptide sequence says, for like the peptide sequence from our gene model. And again, this is a student's gene model. And all you need to do is go to peptide sequence, and this is going to tell you the sequence here. Go in, give it a copy, and then you can go to Interpro. The way this works is just like any sort of multiple sequence alignment program or any of these other bioinformatics programs. You want to scroll down to where the box is. We're going to do search by sequence. We are going to paste our target sequence. And again, you can double check, see how it says that header right there. We're going to go into our gene model checker Yep, that is the exact same header. We like that. And this is the peptide sequence for the gene in the target species. So we put this in, and then we're going to hit search, and then we're going to wait a minute. And the great thing about Interpro is it saves for a certain amount of time all of the searches that you have done. So this one isn't showing up here because I had the student do it on their computer. But here you can see the CycG from Drosophila melanogaster that I searched earlier in order to get this result here. So that's processing. All right, so I timed that and it took 47 seconds. So this is the peptide sequence for the putative ortholog for CycG and Drosophila erecta, which is what the student came in asking questions about. And here, and of course, you can actually change this so that it's easier for you to remember. So we could go CycG D erecta. So that way when we go through and we look at these jobs that are in the cache, we can easily identify them. So what do we see here? Again, we're going to go to options and put the name for all of these. You can actually uncheck a session too, because right now we're looking to see, are all of the domains accounted for? And they are. And where are they located? They are located in the middle of the gene. And because of that, now we can reason that this change right here does not have any impact on the function of the gene.